Hi everyone, my name is Vivian Zhu, and this is my CS109 challenge project about the significant study of socioeconomic factors on gun violence. Gun violence remains a pressing issue, particularly in the US, where mass shootings and suicides are on the rise and on the news. Today, I'll present a data-driven study analyzing socioeconomic factors influencing gun homicide rates across 181 countries. By leveraging p-values and using a multiple logistic regression model to pinpoint the most impactful factors, my goal is to inform targeted policies to reduce gun violence. A critical part of the study is to gather data that is trusted and unbiased. So I got sources like the World Bank, UNODC, and the World Population Review, covering factors like all of these you see here. Here is my data spreadsheet, which shows key variables like gun homicide rates and incarcerations at the top for all of these 181 countries. So to prepare the data, I used Python to address the missing values and fill them in with country averages using Pandas fill NA method. I also standardized numeric formats and normalized features to account for different scales. So now we talk about the model. I used a multidimensional linear regression model to model the gun homicide rates with the equation HR equals theta transposed x plus z, where z is the normal distribution. The model was optimized numerically, and it was followed by the lecture code in CS109, achieving a mean squared error of 0.623. This low error indicates strong predictive power, but the real breakthrough came from the feature selection using p-values. P-values were central in identifying the most predictive socioeconomic factors. A p-value, as taught in CS109, measures the probability that a factor has no relationship with gun homicide rates under the null hypothesis. I set a threshold of p less than 0.05, as we learned, for statistical significance. And here are the results. The Gini coefficient of p equals 0.006, the Human Development Index of p equals 0, the incarcerations of p equals 0, and the burglaries of 0.035 emerged as significant predictors. By focusing on only the low p-value features, we eliminated noise, sharpening our model's accuracy and ensuring only the most relevant factors drove our predictions. And you might be wondering, why do p-values matter, right? But p-values are very transformative because by rigorously testing each independent factor, we ensured that our model wasn't diluted by these irrelevant variables. For example, like the Gini coefficient of low p-value indicates a strong link between income inequality and gun violence. Similarly, HDI underscores the value of human development, but also the opposite, like what's not significant. This method allows us to confidently prioritize features that matter the most, making our findings actionable for policymakers. Now we used this prediction and by running our model, guided by these p-values, producing accurate predictions. So therefore, in conclusion, p-values revealed that Gini coefficient, HDI, incarcerations, and burglaries are the strongest predictors of gun homicide rates. These findings point to clear policy actions: reduce poverty to lower income inequality, invest in public health and education to boost HDI, and address economy-related crimes like burglaries. By targeting these significant factors, governments can implement focused interventions to reduce gun violence effectively. This study shows that data-driven insights powered by p-value analysis can guide us toward a safer future. Thank you for listening.